Thank you, guys. Yeah. Okay, I'm gonna share a couple of practical examples, like what I did in my career about like LLMs and how to implement them in the call centers. There is like interesting component of like how you actually like process calls and how you process voice part of it. So like the part of the presentation gonna be related to that. Other part is gonna be like related to the agentic components and like how to implement agents in like your pipelines and et cetera, et cetera. So let's begin with the, that's gonna be difficult for you guys. But the idea is that like you have a call center, and call center works in the like different stages. First, you have like some technical elements of it. Like whenever the client comes to you, you probably like called all the call centers, and like there's IVR, something like it's called that process like your initial request. Like you probably like know how it's like put one to go to some direction, like put two to go to another. When the like time changes and like when it comes to the LLMs, you usually don't want users to like go through these like AVRs because like it takes a lot of time and users gets annoyed by that. You try to replace that part with some LLMs and like chatbots and like basically voice agents that can process like your requests and redirect you to the like based on your intent and to the right section and based on the like what the information you actually need and probably like to the real agent if it is actually necessary. Because like the idea of the like automatization of call centers and like why call centers actually send you to these IVRs, it's because like they try to save costs. Like human hours is like really expensive, and especially like in the US where I did these projects, it's like extremely expensive. And if you save like just like 1 or 2% of like people's time, it's like huge improvement in the amount of money that like you can get from it. The idea is that like on the first stage when the client only comes to the like with the problem to you, they can come to the website, they can come to the to your voice agent, and then when they come to your voice agent, like you have some like LLM, as I said, like you just have voice agent that process like your request. The problem is that like whenever you come to the latency and the problems related to the connection times between the like text to voice model, voice to text model, and LLM itself. Like if you just like type something in ChatGPT, you probably remember that it takes like 5 seconds for it to think about it. It is the time that like people don't like usually like to wait at the line. It's fine for the texts and chatbots. It's not fine for the voice calls because like the person is going to be like waiting for a long time, and they're probably going to drop or like get angry and start like saying, I want to connect to a human, to a human, to a human, and then like we don't know what to do with that. So like there is another solution that is like part of that. Sometimes you want to redirect people to the humans actually and support humans that answering your calls with the LLMs, because like sometimes it's like really more productive and helps much more than like having a voice agent. Because like whenever you have a conversation with the person, you can collect all the information from the conversation instead of making people like actually type and find the information. You can pull it up from the database and allow the person to just like not writing like live SQL queries, so like typing like login or password of the person who comes with the, like just providing them a way how they can just like grab this information from the conversation and use it on the live in the live way. There's also like some component on like how you analyze the calls afterwards and how you form the response to the client. Sometimes like you need to if it is like utility client that I've been working with a lot, there is like component when you need to send a report to the client because like it is law enforcement and say that like what actions you did afterwards. So like you can record all this information, send it to the LLM and process it and send the report to the agent or directly to the client so they can send it without spending much time. So this was the first part. Can you click to the next slide, please? Because like clicker is not working anymore. And the previous one, because you skipped one. Okay. So this is just like a split of how your time is divided between different components of the conversation with the agent. So there is a like huge part that is related to the like authentication of clients and getting the initial request of like intent of the client, what they actually want. That was previously done by IVR, but IVR is not like able to get all the ways how we communicate with them. For example, like if we are working with utility, sometimes like sometimes client call, hey, we have a like outage in my region, and to authenticate in which region they have an outage, we need to collect their address. You can't collect it with IVR because like there is no way to put like it on the like phone like number 1 to 5. There is like no way to get the actual address of the client because like it is some Yerevan street, I don't know, Pushkin, and house is like 3. And you cannot get it with like simple ways. Like you need to process that information in like natural language processing ways. And then you have a like huge part that is like related to actually like solving the client problem, and that's like where you sometimes can use and like can't use LLMs because like there's parts where you need to collect information from the databases, and as I said before, the clients don't like to wait on the line for a long time. This is a representation what we did. Basically, like to solve this problem, we implemented on like in our process like multiple agents that process different elements of the conversation. For example, like you have agents for the connecting to the database to process the conversation and provide the summary. You have an agent that takes information and collects data from your CRM system about the client, and et cetera, et cetera. There's like just multiple agents. Some of these agents just like implemented for railguards because like whenever the client calls you and your utility company, if the clients ask you, where can we walk with my dog, for example, you don't want to answer this question. Or if it is like something even worse, what is the revenue of a company? You don't want to send this information to your database and answer this question to the customer. Like you just like try to derail it and like end the conversation, or just say like ask the relevant response. So like you need to have agents for all of these parts, and we just like implemented them as like separate blocks of code that like you can embed into the general pipeline. And general pipeline, it's like usually if you worked with like LangChain, LangGraph, it's like we started it before LangChain and LangGraph was created. So like we created our own state machines and our own way of like pipelining. Right now I would do it like with the tools instead of like using like your own scripts, but like we did it that way. It was like actually fun because like we created state machines because before the LangChain actually come up with the idea to the market. And yeah, we had different like parts of it. So like you usually have like analyzer, you have the like pipelining tool, you have the part that is like related to the operations and like basically the state machines that operates all the like your agents that you have in the system at the same time. And the use case is like super broad. Like I know that the same pipelines same agents that we created right now currently like used in the company in the way that like, okay, let's embed it into the financial services, let's embed it into something else. But like the idea is the same. Like you always use the kind of the same approaches like LangChain. You have connectors, you have the like agents. It is like small pieces of code, like snippets that do some like really specific elementary task that is not really complex because like otherwise your system is gonna die. So that's how we implemented the agents. Can you actually go to the next slide because like it's not working again? I'm gonna be saying you, please. And this is like one of the examples how it's done. You can have it like just, okay, we need to provide a like report to our client. We have like several agents that collect information, for example, from like MySQL database, CRM, some like external information. I was like implemented one of the like system that collects information from external news sources. Whenever like you want to have a like outbound call center that connects to the people and asking about the like their information in the utility. For example, like if you want to connect to our services, you probably like if you're working with huge companies, you monitoring information about like changes in the board of the company. You monitoring information in the like if they building a new plant, for example, like if it is mining company, they building a new plant, you figuring out it from news. And if like you're huge utility company that provides electricity to them, like you can grab that information and process it into your system and just like call based on that information. Like you just say, hey, I see that like you plan to build something in the new region. I just want to have a conversation with you. You can give me a number to the like representative that is I can connect. That's like what LLM usually does, and then like you actually call with the human. The problem, like as I said before, sometimes like you have huge issues about like how you actually like work with the requests. Intent is like really unclear in the beginning, and there is like really difficult parts related to the safeguards. The companies like they tend to not allow you to move to the LLM systems because like they kind of scary if the system is gonna say something like completely wrong. And there's like where you need to have a lot of safeguards about what the like LLM can say if it's like gonna be sharing some information that is not appropriate, if it's going to be like, I don't know, rude to the customer and etc. So like you have a bunch of issues that you're working with. So can you go back for a second? So like there's hallucinations, of course, like everybody knows about that. There's like user information about like how you like, what wording do you use, like what the data you share, and etc. So there is like a bunch of things. Can we go to the next? What we basically did? Can we go? Yeah, what we basically did, we created like some separate module that allows you to embed that into your agent's code. So like you have an agent, but like you create something on top, and that like every time you process that data, you basically like send the output of your LLM to another LLM to verify your answer. And it's sometimes like multiple parts of it. So like there is multiple like different analyzers that check if your response is fine. If it is not, it sends to another LLM to fix your response. So like as you can see, there is like some like basically like a huge orchestrator. We call it guards that is like orchestrates all these rails that we have rails that tries to analyze your response that generated by LLM and then try to fix it if it needs to be fixed. So that's what we did. We created a like module that is orchestrates everything on top of your answers. And you can embed any analyzer and you can embed any checker that you want in any character. Can we quickly go to the next one? So there's like multiple analyzers and checkers that you can find on the market. So some of them is like provided by LangChain. There's like one that they trained on their data that provides you different categories. What is wrong with your response? There is like one that is like OpenAI uses like whenever you just like try to find some inappropriate information about like, for example, if you try to make a picture of the political figures on ChatGPT, it's not going to provide you and not going to allow you to do that. The same with the like voice and text responses. Like if you ask about some political thing, it's probably not going to answer you. So that's like what they do, and you can just grab that module to your code as well and ask it to analyze your responses for other LLMs if you're not using ChatGPT or something like that. There is like, we also implemented our own model based on the transformers of Hugging Face, but like it's just like simple thing. You can take like any data set that you want. You can grab like transformers from Hugging Face and like just implement the checker that you want, like basically asking what you actually like want to analyze in your response. Can we actually go to the next one? And this is like a bunch of things that you also can use. Like you probably can check the presentation later because I don't think that like you can see everything. But like the one that I want to say about, there is like Microsoft PI analyzer that like analyzes if there is like personal information in the response. Most of the time you don't want to have like any personal data that you even share to the client that asked about that data. For example, like if you call in the bank and asking like, what is my card number, then they're never gonna say you that. The same for utilities. If you're gonna call them and say like, hey, I'm like Max Pershin and I wanna know my address, they're not gonna share that information even with you because like they're not 100% sure if it is you. So like there's like some tools that you can embed into your code to verify that there is like no such leaks of data. Can we go to the next one? Whenever you've actually like found that there is something wrong with the response, there is a bunch of checkers. So you have we implemented once based on the LAN chain. We implemented once that is like based on our own code. For example, like sometimes it's just rule based. Like you just verify that there is like if there is some data that is wrong, you can resend it to another LLM or just like with the specific prompt that is saying like we can't analyze that. Okay, can we go to the next one? This is going to be awful because of the echo. I just try to share example of the tool that we implemented, and there is like a huge problem with that. I'm gonna say, if you make it play, there is going to be like, hey, I'm like person, I want to authenticate in your call center, and the response is going to be in 10 seconds, because like there is a like huge part related to the like, okay, you have safeguards. You have the request to the, for example, like database, because like if you get the question about like you need to verify password, login, or like address and name of the person, there is a part related to the, like generating output, part related to analyzing the input, etc. It usually comes up to the situation when you have like 10 and more requests to different LLMs, and like if each LLM responds in like even couple seconds, it's already 10 seconds that the client need to wait on the line. So you usually try to figure out the ways how to avoid that. And can we go to the next one, the last slide that we have? Sorry. Yeah. Oh. I don't know, like if you're gonna hear. So like if you start counting seconds here, it's going to be like a really long time. It's one of the first versions that we implemented. And yeah, I can't help you with that because like the person asked about like, can I walk with my, like where I can walk with my dog. So like we just like process that request with multiple lamps, and it's like we can't find the right thing to do with that. But the problem is like wait time. Yeah.
Did you consider putting some keeping conversation alive while processing, basically some phrases?
Yeah, I gonna share. So there is like multiple, like what you need to do with your project if you implement something with the voice agent. There is like speech to text part. That's like the most difficult one because like until the clients stop talking, you can't analyze the request, and you just need to wait to figure out like when they finished. So there is like couple technical things. There is like there is chunks how the text analyzed, and if you reduce the amount of like the length of that chunk, so there is like finalized sentence of the person is going to be like provided faster, so like you can reduce this amount. You can like use lighter models, but this is something that I'm not recommending at all, because like whenever you use lighter models, it gives you like a really small amount of time that you can get, but you're probably going to get much worse results in terms of the like quality of your input. And input is like super important, because like whenever you losing some words in the input of the person, like you're losing your intent, you're losing everything, and your response is going to be like completely off. The next part is related to LLM itself. Like sometimes you don't need LLM at all. Most of the time you don't need LLM at all because like to just get in the like named entities from the conversation, for example, address, you don't need to use LLM for that. You can like use much simpler models. If you need to analyze the like, I don't know, basically like some small database requests or like some requests to the like text, you can just try to like to pre-build this information and put it into some files and don't like and take it from there instead of like sending all the like text to the LLM and grab it from there. Sorry, can we go back for 1 second? Couple things about like text to speech. Streaming is super important. Whenever LLM starts to generate output, you start streaming it to the client immediately. You're not waiting until the, like everything is provided. There is a couple like things that you can do with your client instead of like just giving them like waiting for the whole response from the LLM. You can just like, hey guys, wait a second. I'm gonna analyze your stuff and then process everything. Or you can add background noises. Like we actually figure out that it is like super helpful with the client. When they like call the call center, they expect to have background noises. Otherwise, they start thinking that they're speaking with the robot. Like most of the time, you try to avoid that because they switch into everything else. Try to find the like human conversation with a human. So like you just add background noises, and people like they lost. They think they're actually talking to a human. There's multiple tricks that you can embed. Like whenever you expect like long request, you just like add, wait a second. Whenever like you get the response, you don't send everything to the LLM. You just say, okay, I got it. And it's like simple phrase that is not generated by your LLM because like it gives you some like immediate response to the things that the client said. Also, like super important thing to badge in. There's like if the client starts talking again, you need to stop your output. You need to start getting your new response because like if the response is like completely off, the client is gonna start saying something. Yeah, I don't like the response. Like I want to talk about something else, and you need to rethink and reprocess your input and output. And there is like a huge thing about like infrastructure. You need to keep your servers close to the client. You need to have like everything multi-processed. We rewrite everything from Python to Go eventually because like it didn't work for Python at all. Like you can't have like multi-processing. Every LLM that you have in the pipeline, if it's like 10 safeguards that like you have, you need to process them on the parallel way. You can't process them like sequentially because like it's going to increase the time. So this is it. The only thing that I can say about call centers at the moment, all the companies try to completely automatize their call centers. Now they figure out that it is not working in the world, and they switch into the actual support agents. So the first part, like for example, authentication is processed by LLMs and voice agents. Then they send people with the intent to the human and provide information what the client actually needs and process that information online, as I said in the beginning. Like if you asking something, some of the like of your agents on the call saying like, hey, I want to check my balances, LLM grabs that information, goes to the database and provides the output about like your balances, but it's not providing it to you directly. It provides it to the agents that you are talking to. And they actually like respond with like, initially they say, yeah, just wait a second. And they look at the screen, balances come up and they say like, yeah, this is it. Yeah. Can we quickly click through? That's how it works. This is the interface that like one of like, it's not one of our clients' works, but like it's one of the demo that we created for our clients. So like this is like you have information about your client, you have like information about their parameters, you have like information about their mood, and et cetera, like, and there are different parameters that they grab from the. And can you just like quickly like click? That's how the conversation goes. Like you just get an updated information on the screen of how everything works. Yeah, that's probably the end. and everything that I wanted to share. There's a lot of things about like how different elements of the pipeline work, but like if you want to talk about that in person, I'm here and like happy to answer. If you want to check the like specific demos of how it works, I can also share. But right now, like if you have any questions, I'm happy to answer them.
Thanks for the presentation.
Thank you.
Yeah, I just wonder how big of a team did you have to implement this particular solution, and for how long? How long did it take?
So basically, like we implemented the first version when it's only started, when the like ChatGPT created their first version with the team of like probably like 7, 8 people on the client side, just trying to figure out how it works. And that demo that like I presented, like you heard, it was like result of that. It was a couple months of work when we did that. When we created that, I believe like I would say like 20 people working on that all the time for the last like couple or 3 years.
Thank you. Any other questions?
What refers to the streaming of audio, I have noticed that when we stream the audio, the quality is lower than when it generates the audio from the whole text.
Yeah, the problem is that like whenever you generate the output of your audio model, it usually works in chunks. So like it can update the first part of it based on the like latest generation, because like it can see that what the conversation is gonna end with, like the sentence is gonna end with, until it's like it's gonna generate it. So sometimes it updates the first part. I would say like with the output, it's fine to have like longer chunks versus like when you have like it with the input, because like you want to get your input as soon as possible, but like you cannot fight with that. Sometimes you just need to wait. Sometimes like you just like, that's why we move into these like solutions at the moment. You cannot generate outputs fast enough with the current models to make it work with the like direct conversation with the client. That's the point. Like that's what's happening in the industry. It's like, I mean, like you probably all saw the like Google presentation of how it works, and it's like based on my knowledge, they have it. They have all the data in the hot and warm solutions, and that's not how it's working in the real world. You have like information and like your models generating outputs based on like some requests that you send to the servers. Yeah.
On-premises or on cloud?
I mean, it's just a code, so like you can put it on the premise, and like you can embed like any models that like kind of like any cloud models. For example, yeah.
Do you have a problem of quality? Yes, because if you are using OpenAI with API, that's a different quality, and if you have the open source version now, that is a different quality. Yes.
I would say like any customer that I worked with, they usually prefer to use API versions, like enterprise versions of the LLMs.
Okay, then how do you solve the problem of security? How do you, like when you share your client's data with this?
So basically what you usually do, all the cloud providers, they provide your own version of the LLM that is stored in the secure environment. So you can just like request, for example, Microsoft Azure to provide you like version of ChatGPT on their servers. It's going to be like your own servers that nobody going to be able to access. You can include any additional information into it, like and do whatever you want with that.
It's much more expensive, or the price is not high?
I would say for the US clients, it's not that expensive. For the Armenian market, I believe it may be like a little bit different situation. I don't know like about the prices here, about the prices there. It's much cheaper than having a person in the call center.
So, follow-up question to that. Since it's kind of half like a on-prem solution, basically,
Yeah.
because you have your own server, do you deploy actually in different locations? Do the company do that?
Depends on.
How is it structured between your clients and you? You just say you can plug whichever LLM you want. There's like configuration, and then they go on top to Microsoft, or you do it
I've been a consultant at the moment, and like I'm still a consultant. I would say like we never like try to derail the conversation of like how the conversation with our client goes with the cloud provider. So they just like do it themselves. Our solution is like completely custom based. So like you just connect your like we go to your server and we implement everything there. We create like separate elements of it that is needed for you. Especially, it's not a platform. It is custom built solution every time. So it's really difficult to implement it as a platform.
It's not a multi-tenant platform that then you tune for each client. It's every time you implement.
Yeah, because like it's every time like different database that the client has, different CRM system, different like tasks that they try to solve. So it's really difficult to create. I don't know any platform at the moment that provides that like solution that is call center specifically. Salesforce is kind of close to that, but like I don't know any other.
But you have your own like library basically.
Yeah, of course. That's the point. Like we have our agents created, we have our guardrails created. So like we just pick from this library and we put it into your code.
So yes, you said that the main problem is like response time.
Yes.
10 seconds. How are you trying to optimize it? And did you heard about EVA AI? Like they are doing the same thing for call centers, and they are doing 2 seconds, like for response time.
It really depends on your request. As I like on the slide, I showed like a way how we can fight with that. Like you can parallelize everything, you can stream your output as soon as possible, you can use like lighter models, etc., etc. There's like a lot of different ways. The problem is like it's not consistent. It depends on the request that client gives to you. For example, like if I ask you about like, hey, can I get my like balances over the last 2 years, and what I can do with that, like why my current balance is much higher than my previous one, and like my utility bill is much higher for this month is much higher than the previous ones. I need to go to the database, get your data, analyze the trend, analyze like what the factors. I need to go to another like table and probably in the database, analyze the factor what actually happened to you, why your bill is much higher, send it to some like LLM with all this information, ask it to figure out like what the reasons and come up with an answer. It doesn't matter like what LLM and like voice to text and like text to voice model you use. All these requests to the database is going to take like 10 plus seconds.
So it's the median time, like not the maximum value.
It just depends. Like I mean, medium time maybe like 2 seconds. It may be much faster if you like just including all this like greetings and etc. It's going to be like super fast. It's not going to sound to you like it is 10 seconds anyway with all these like additional modules and like embedded things. Like if you ask something, I'm going to respond to you immediately, but probably there's going to be some delays at some point. Yeah, I can show you a demo if you want.
Yeah, just 2 quick questions. First, you mentioned that you have like many agents, and each agent has its own prompt.
Yeah.
I always had this question. Actually, can you somehow optimize it so every time when you call an agent, you don't give every time the background prompt, or how do you optimize it? Because it may not be like too much money, but if you do it like tens of thousands of times, like if you can somehow just store the prompt in the prompt, somehow cache the prompt. And the second question, can you also like talk about a bit about your experience? How do you debug this agent change? Not in terms of syntax, but like if anything goes wrong, like at one point, how do you determine which prompt was bad, like in the chain?
So like regarding the second one, everything is like logged. Everything is like connected to the database that you analyze your responses. You send these responses to some like people to validate after the conversation. You send it to the LLM to actually like analyze. what's happening. And there is was a part that is like on the first slide, there was a part that is related to the coaching. So like you also analyze the same thing for the people actually, like trying to figure out what was wrong, what was the if the client was angry and etc. Like what can be done better. So and you provide the coaching for the system and for the people. So whenever to debug it, it's actually really great question about if you actually working with the model, how to debug it. At the moment, if you send some responses, it's really difficult. We have ways of doing that. We have a database with the requests and expected responses. You measure the differences, and it's especially for the small one. For example, if I try to authenticate the person, I have name and address and etc. I expect that it's going to be authenticated. So we have this database. We have a database related to questions about weather, bills, etc. So there's you try to train your model, you're not training your model, but you validate your model with these data sets. The same thing that you can do with your, if you analyze the conversations of the client, you have the request and you have information about outcome. For example, if the client was authenticated, if the if your client is mature enough, they track this information into their background call center system, whatever they use, but they have information about based on what request the client got, what response, and what action was taken. So you can try to validate if your LLM provides the same things. Sorry, about the first one.
About the cache in the prompt, basically.
Yeah, about the cache in the prompt, we try to do that. Every time the request is completely different. All the things that you can cache about your requests, it's usually about greetings and etc., but not to the specific point. That's yeah.
Okay.
Yeah.
Okay. Somehow not to pay for the prompt every time.
Yeah.
Because the prompt is long and then it's a short question, so somehow not to pay every time for the prompt.
It's kind of, no. There is two parts of the conversation. Usually you store your short-term memory. It's a bit bigger discussion about how your pipeline works, but it usually works as some pipelines that embedded into much bigger pipeline that is orchestrated. For example, you have authentication module, and inside of authentication you have address analyzer, you have something else, there is maybe different steps of authentication and etc. Multiple stages of it. So you usually store high-level memory. We call it long-term memory that is stored for the whole pipeline, for the whole state machine. And then you have elements that related to the specific conversation that you have with the client right now in the current pipeline, in the current conversation. So you need to have these both things sent to LLM. Sometimes you don't need to have that sent. Sometimes the long-term memory, if you just creating small output, for example, you saying goodbye to a client, you don't need to have the long-term stored prompt into that request. You just saying say goodbye to the client. That's it, end the conversation, and you don't even need LLM sometimes for such type of things.
Thanks a lot.
Yeah. Thank you, guys.